Hello everyone and welcome to another Directions Mag Geospatial webinar sponsored today by our friends at Hexagon. I'm Barbara Duke, Managing Editor here at Directions Magazine, joined by our assistant webinar producer, Lynette Qualia. If you have any questions about your connection, just drop us a note in the chat. We encourage you to stop by directionsmag.com to read our newest articles and daily news. We're standing by to take your questions. Type those into the question box at any time during the webinar. We'll answer as many as we can at the end of the session today. We are recording today's webinar, so keep an eye on your inbox in the coming days for that email with the links. And we appreciate your opinions on our poll and the post-webinar survey. Today, we are excited to have Sebastian Elson with us today from Hexagon. He has some great new applications and features to share with you today. A lot to learn and some wonderful demos and examples. Sebastian, welcome. We are excited to have you with us today and excited to learn more. Welcome.
Thank you, Barbary, and welcome everyone to this webinar on how to build dynamic geospatial applications, a better DX for a better UX. And I'm going to start off by maybe explaining a few of those terms already in the title and some terms I will be using throughout the presentation. Many of you will be familiar with these, but I just want to make sure that everybody is on the same page with the abbreviations we use. The first one being DX, that refers to the developer experience. So we're going to talk about how developers experience using tools like SDKs, which I'll explain in a little bit, and how that experience should be as smooth as possible so they can focus on making nice and beautiful applications that improve the UX. And UX means then the user experience. So that is the experience that the end user will have working with the application and interacting with it. Of course, you also want that to be as smooth as possible so that the user is comfortable using the application and will use it as much as possible. So we do that by providing SDKs, software development kits. So as the name indicates, it's a kit that offers developers all kinds of tools to help them during the development of an application. And that for one can be an API, again, which I will explain in a second, but it also includes samples, documentations, and support. So API finally refers to the application programming interface. Now, very often I myself as well use SDK and API interchangeable, but API really refers to the interface, the coding interface, usually in a specific developer language that a developer will use to access the capabilities available behind that API. So those are some terms that I will use throughout the presentation. But then let's go to the question at hand, how to build dynamic geospatial applications. And who better than the late Steve Jobs, of course, would have the answer to that. And his answer is, you've got to start with the customer experience and work backwards to the technology. And to start from the customer experience, we believe it's important to ask them the right questions to get the right kind of information to tailor the application for them. And I have a few questions as examples. One of them, for instance, can be, what kind of information does the user need? In this case, you can see we use an aggregated view, as we call it. In this case, the user just wants an overview on where the hotspots are during the violent events around the Syrian conflict. And an aggregated view like this heat map or hotspot map immediately shows up in red where such violent events occur more than in other places. If this is the requirement to have such an overview, like the reporting view, there is no need to show all the details of all these specific events in the application. We'll just clutter the view for the user. Another example is to show to ask what features the user needs and only stick to those. In this example, for instance, we are showing a little screenshot of an air traffic control application, and those are known to be very simple looking applications because they're so critical for the aviation industry and of course the safety of aviation traffic. You don't want to disturb the users with all kinds of information and menus and buttons. They only need the information at hand. In this case, for instance, a dark background with the geospatial border of a country or a state, and of course the tracks of the airplanes with the relevant information in labels. Another question is, how is the user then going to interact with the application? And in this example, for instance, we show an example where the need was to interact through a touchscreen, taking into account that the user might have gloves. Well, in that case, you want to have big buttons in the user interface, so it's easy for him to press a specific button to open up a specific feature, even though the user might have gloves on. If you start working here with multiple menus, embedded menus, and he starts clicking through little buttons, it would not be very usable for this user at hand. The next one is, how will the user interact with the data? Again, a very important one. In the beginning, it was how he wants to view the data, and for instance, in an aggregated view, just a heat map worked fine. But if he really wants to interact with the individual data, also there we need to think about how can we make that as easy as possible and also as relevant as possible. In this little screenshot you see here, we are showing all tweets around the city of Paris in France. But on the left top side there, we provide some filters. And those filters are the most often used tags in those tweets. So we analyze the tweets, we retrieve the most often used tags and only show those for the first initial filtering. And as you will start creating filters, new tags might pop up that become more important in that subset of data. If you would start off by showing all the available tags in the data, again, you would clutter the screen and the interface with information, and it would be hard for the user to navigate and interact with the data. Another example you can see at the bottom is, for instance, an interactive timeline view, where you can just pan and zoom on that timeline to filter out data of a specific point in time. And then the last one, one of my personal favorites, what view on the data does the user want? And here it's important not to start from what is on offer, because the user very often is guided by what he sees. So very often we start off, just tell us how you would ideally want to see this data, not how you are used to seeing that data. And in this example, I'm actually using a recording of an application where we did that exact interaction with a customer. So we started off by showing this weather data in the traditional way, the 2D draped image on the map. But he wanted to see the data along a flight route. So we created a vertical view, as you can see here on the right, along that line. But why not add that vertical view to a 3D view and actually put it in, well, kind of like you see here in the image, really integrating the vertical view with the geospatial view, which the customer very much liked. But he said, if you can do it in 3D, can we also do full 3D? And that was the point where we really started interacting with the customer, and he started giving input, seeing that maybe anything is possible. I'll just ask them what I would like, and maybe they can do it. And that is exactly what we did here. We took the weather data for the different slices in height and visualized that in 3D. This was a way that was never done before, but was actually the way that the customer would prefer to see this data. So after asking all these questions, the idea is, of course, that you develop an application that fits the needs of the customer during operations. And there we come to something that we at Hexagon call the GeoHops challenge, because now you know how the user operationally wants to use the geospatial information, and you know the geospatial information, but how do you now combine those? How do you bring that geospatial expertise, because handling geospatial data is an expertise in itself? How do you bring that into the operational application as a developer? Because maybe as a developer, you don't have that expertise yourself. but of course you still want to offer it to the user. And that is where the SDKs come in, the software development kits that improve the developer experience to integrate such complex features like geospatial expertise into the applications, so they can focus on improving the user experience for the end user. So what you get is the user can choose the system architecture and the developer can focus on how do I build the application that fits that need of the user, what platform he's working for, what setup he wants, server clients. The developer can focus on that, and the SDK takes care of making sure that everything works on every platform, so the developer doesn't need to develop anything particular. Same for the UI. The SDK should allow the developer to build a fully custom UI that fits the needs of the user. But maybe it's also useful if the SDK already has reusable front-end components that the developer can integrate into the user interface. It will also allow the developer to focus on the user requirements. Through the SDK, he can add what is needed, of course, all the requirements of the user, but also add only what is needed. If you would start from a finished application, what you would very often get is that application might do what the user needs, but also do 100 things more, which makes the application more complex for the user and more cumbersome to use. So through an SDK, a developer can really pinpoint that exact feature sets that the user needs. And finally, through SDKs, you should be able to build future-proof solutions, long-term solutions that can evolve with the user needs. Through the SDK, you should be able to easily add features to the end user application whenever the user comes with new requirements. So an SDK is a very important concept to improve the developer experience and ultimately will result in better applications and improve the user experience. But I want to highlight here that you should be careful when choosing such an SDK. For me, for instance, I think you should choose an SDK that is an SDK by design and not by disaster. What do I mean with that? If you have an SDK that is an SDK by design, you will see that it's built up from the ground to address the developer experience. It's to make sure that the developer has an easy interface to add features to his application. By disaster, I refer to when you have, for instance, a finished application and you're going to start to break that down or drill holes into it to maybe allow for an API so a developer can do some customizations. But what you quickly will see is that when you drill such holes in an application, you start seeing or experiencing problems. And the image here shows that nicely. If you have bricks and mortar, you can build a house however you want it. If you already have a house and you want to drill an extra door somewhere, it can easily go wrong. If you say I want an extra door to enter from the second floor, that might be possible, but if there's no stairs foreseen, you cannot access the door. If you want more examples of this, I urge you to Google like building projects gone wrong or something. There's some pretty fun images that will come up where you see these doors that do not align with the architecture of a building. And that is very often what you would get when you go from application to SDK rather than SDK by design. So the developer experience stands or is improved with an SDK. So I think it's time maybe to ask the question to you guys: what do you think is important in an SDK? And we have a little poll there to test that.
Coming in first place, extendability and customizations. Second place, documentation. And then in third place, the language of the API. Excellent. Those are good insights. We appreciate you sharing your thoughts. And back over to you, Sebastian.
Thank you very much. And that is interesting indeed, because I personally would have expected that the language would have scored higher, but it's good to see that most people are very open to use whatever programming language is available as long as they have the much needed flexibility and customization options. And because that is also what I just highlighted, you want an SDK by design that you have full customization options and you don't get stuck like you saw with that door example. So what we at Hexagon have to offer as SDKs is what we call the Luciad portfolio. So those are really SDKs designed for building dynamic geospatial applications. And they are designed like that from the beginning. It all started in 1999, where the founders of the technology really wanted to address the geospatial needs that GIS could not resolve. And one of them was building custom geo-enabled applications. They did not want to use the sometimes bulky or complex GIS systems that were in place for mission critical use cases where they very often just needed a simple but very clear application. Another one was handling dynamic data, which is again something that traditional GIS was not necessarily designed for. Also the ability to integrate that view into other systems. Because what they realized is more and more of these systems that before might not have a geospatial view could definitely benefit from having such a view. So why not enable to integrate through an SDK such a view into existing applications? The founders were also active in the defense and aviation sectors, so they all also wanted something that could have been there for the long term. If you develop a project today, they were aware that it should have run for at least 10 years or so, so they wanted to enable that as well and increase the reusability of components, that they could use or reuse components in different projects. Secondly, they had a very strict domain focus. They started off with defense and aviation, but as we've seen over the last 20 years, that has evolved, of course, and I think today almost every application with a geospatial view has a certain complexity in the requirements. Think about smart city, for instance. These applications all stand or fall with a good geospatial visualization where you can do quite mission critical capabilities. So any kind of mission critical application should benefit from using the SDK. So regarding DX and UX, what did they do there? Well, for the developer experience, they thought we should use the latest innovations and technologies, but hide the complexities of those behind the API. The API should be accessible for developers, but behind the scenes, we really want to enable complex things like OpenGL development for 3D rendering. It's quite a complex thing, but by providing the right level of API, we can hide those complexities and make it available for every developer. Another thing was to offer a solution for all platforms. For the user, it's important that you have high performance and accuracy. Performance usually is also about interacting with the application, having a smooth experience when you pan and zoom on your geospatial map, for instance, that it's not stuttering, but it's all smooth when you do an analysis, that it's instant, so that you can immediately get the information from the geospatial view. Also, by offering front-end components, and not just any components, they really work together with specialized companies for the design of the front-end components to make sure that if a developer would use them, he could benefit from those well-designed components, and the application would look beautiful for the end user as well. And of course, finally, regularly adding new features upon request of the users. So the users actually got a say in what new features were added to the SDK. And by doing it that way, the SDK got improved with features that the developer could very easily access, but the end user needed. So the developer could easily add features that the user asked for through the SDK. So the SDKs available are available for every platform. Little overview here, but as you can see, there's server, browser, mobile, and desktop onboard solutions. They all stand powerful on their own, but of course can also completely interconnect through open standards and so on. So there is an SDK for every developer's need. And in a lot of projects, you even use a multitude of these. And a good example of that, for instance, is in the Mirage 2000D, a fighter jet. In the cockpit there, we use no less than 3 of these SDKs for developing solutions. So there's a Luciad Lightspeed-based applications embedded on the touchscreen for the co-pilot. Also, the pilot has a view based on that technology, but he also has a tablet where Luciad Mobile, of course, was a better fit. And it all is strung together by providing data from the Luciad Fusion server that is running on the onboard computer. So by mix and matching the SDKs and putting them on the right platform, we enabled multiple developers on multiple parts of this cockpit to provide the right solutions. So what are the main benefits of these SDKs? What do they bring for the developer? Well, first of all, it's component-based for maximal flexibility and reuse. It's clear components, so they're clearly separated based on functionality, and they kind of make sense. The text on the diagram on the right might be a bit small, but you would see, for instance, near the bottom there, the optional components regard aviation standards. And that component contains all the aviation standards you could possibly need. The same for radar connectors or maritime standards. It always is a nice, sensible package of additional features that add to the SDK. Although they are components, they are all part of a whole. So they follow the same principles and can be combined and changed as needed. And that is also an important thing in an SDK that works through components, that it's not components built by different institutes and they don't really fit together. If they are component-based, in the end, you should not notice that you're working in different components. They should all align with the same design. It's cost efficient, of course, to work through components because you only need those that you want. Well, get those that you need, let me put it that way. But maybe the most important thing for the developer is that a component-based approach also inspires component-based development. And if we can inspire developers to build their own components based on the components and the SDK that we offer, then he can reuse that more easily in different projects and minimize the work to get, for instance, the same feature in a multitude of applications. Similar to that, also a good design leads to a good design. And these SDKs are developed, well designed from the ground up. So typical development patterns, as you will find in the famous design patterns book that you see there on the right, or model view controller and builder, they were applied from the very beginning. And it's interesting to see how these still stand strong today. So still today, many of these patterns, many of the API within the SDK is still virtually the same as 20 years ago. And it's not outdated, it is still a very modern API. But of course, the whole idea is that this should also inspire good design. If you're using this builder pattern numerous times through the SDK, hopefully you will also start applying it in the code that you custom write around it. The SDK are in it for the long run. And the most important part there, I think, is the backwards compatibility, because that's, especially for the developer experience, very important. So he can easily upgrade, benefit from new features, benefit from improvements in new versions without having to put in all the work to upgrade. So if you look at the comment there on the right, that is not how it should be. You should not have to start from scratch every time a new version comes out. So make sure that if you choose an SDK, that backwards compatibility is high on the list for the providers of that SDK, so that you can build applications for the long run. Also, long-term maintenance and support. So these SDKs in some projects are supported for over a decade, remaining on the same version, but still offering full-on support for any issues they might encounter. Consistency. throughout the versions, but also throughout the products. If new products or SDKs come out, they're all very consistent. So if you learn to work with one of these SDKs once, you will very easily adopt other SDKs in the portfolio, or of course keep working on it throughout the new releases of these SDKs. And then transparency in upgrades. A lot of the applications that you build with the SDKs will actually improve automatically when you upgrade. So keep in mind, upgrading is easy because of the backwards compatibility, but you also get free wins because the performance might, for instance, already get better, or you might have additional format support or drivers, which is actually what I want to address here as well. With the SDKs, and I think, again, this should in general be the case, you're developing with the power of 10 developers or more. You have these continuous improvements that are done behind the scenes. You develop your application based on the API, but every time you upgrade, the application might get better without you needing to make any changes to the existing application. And a good example there is, for instance, adding use of latest technologies through a minimal amount of adjustments. And we did that for the browser-based SDK, Luciad. So we added there support for GPU rendering. So for those familiar with web-based technology, it went from canvas to WebGL rendering. And all you needed to do is shown there in the little animation. You just added WebGL in front of map, and everything else in the application could remain the same, but all of a sudden you were starting to use the GPU for rendering. In an application where you wanted 3D, that meant doing that small addition, adding the WebGL, and then change the reference to 3D. That was all you needed to do to have your exact same application enabled in 3D. So that's the kind of benefits that you want, because they can really speed up the development, improve the development experience, and again, the topic of the presentation, that will ultimately improve the user experience. This is, of course, a continuous effort. The world evolves, and so do we. So a few examples of that are, for instance, continuous documentation upgrades. It started up by offering an online development platform, for instance, which makes it very easy to search through all the documentation, but also making the documentation interactive, as you can see there in the little video, where you can just browse through the different parts of the documentation very interactively, and you get your code snippets and everything that's relevant for the functionality you're looking at. Another thing is the evolution of Java. So we have some products based on Java. The Oracle JDK has evolved over the last 20 years, and of course we followed that evolution with the SDK that was based on Java as well. A few years ago, even adding support for OpenJDK to fully offer the user, the developer, the option to use Oracle JDK or OpenJDK, which could also have implications for the user licensing, for instance. Another example is the adoption of JavaFX, where for already quite some years you have Swing as the main front-end component in Java, where you have menus that look like this. With JavaFX, you can really modernize your look and feel with components like this. You have nice shading on the buttons and everything. Again, the application will look better, the user will more easily adopt it and like the application more. And then finally, adding new products depending on the needs. Luciad C Pillar, a C-based, so both C++ and C# based product, was added recently. But also Luciad RIA, the browser solution. We follow evolutions in new technologies and new kind of developer options that come up, like providing it as ECMAScript modules, making it available as NPM packages or TypeScript definitions added to the product. All of those things with the sole purpose of making it easier for the developer to use this technology and for him to make better applications for the users. Of course, this is all about how to use the SDK and the benefits of the SDK itself underneath, and we can't address that in this presentation, but you should of course have rich capabilities that you have access to through the SDK. Think about handling multispectral analysis, draping video, handling 3D buildings, and so on. All of these features should of course be made accessible through the use of the SDK in an easy way for the developer. So I hope I've kind of painted a nice picture for you guys and inspired you to try this out. And you can all do that. Since recently on our developer platform at dev.luciad.com, there is a free 90-day trial available for some of these SDKs, complete with a tutorial to get you started. So feel free to go there, download it, and have it go as a developer. And yeah, feel free also to contact us, of course, for any more questions, specific questions on these products. And talking about questions, I realized I used up all my time, but maybe we can still squeeze in a question if there are any.
Yeah, so I'm going to try to squeeze in just two very quickly here, Sebastian. So first of all, you mentioned programming languages used within the Luciad portfolio. Could you clarify what those are?
Well, it's a wide variety these days. In fact, there is products that work with Java. There, for those that prefer C++ or C#, we have a product that supports those languages. The browser-based SDK is JavaScript-based, and the mobile one is Android-based. So it's a bit for everyone's taste. I think there is a product for that. And that's really the goal, to offer a wide variety, again, that developers can use as much as possible what they are familiar with.
And so this last one, I know that you've been talking about developers, and so someone's wanting to know if the Luciad software is a fit for developers only, or if you also provide something more ready to use out of the box.
As a rule of thumb, I would say that the Luciad portfolio is for developers. It does contain a lot of end user components already that you could basically just deploy and start using. But even that deployment step, in my opinion, is a developer's task. So there is still a developer involved. But that was also the topic of today, of course, addressing the SDKs and the developers. Within Hexagon, we have layers on top of that. We have different portfolios that go from final ready-to-use applications for a wide variety of operational use, but also geospatial use. And we have a platform in between that is more focused on configuring apps rather than development. So if those are of interest, also feel free to ask us for more info. I'll also check these questions afterwards, and we'll provide more information on that if that is needed.
Okay, wonderful. Well, thanks everyone for being here today. We really appreciate you stopping by. Remember to keep an eye on your inbox, because we will archive the recording, so you can expect something from us to view that, as well as any resource links shared today. You've got a couple of more links there on the screen from Sebastian at hexagongeospatial.com and dev.luciad.com. We appreciate your opinions on the brief survey on the way out. Thanks again, Sebastian, for sharing your expertise, and to Nellie and Catherine for their help with logistics in the background. Have a great day. Tell a friend about Hexagon, Luciad, and Directions Magazine. Thanks, everybody.